Alright, Section 7, flaw detection. Introduction to flaw detection. The single most important asset of the heavy haul industry is the rail. However, primary concern of the railroad company's profitability of the rail flaw development, broken rails, and resulting repeated application of high contact stress with heavy axle loads encountered today. The result of the railroad companies improving the maintenance practices and increasing the test and the method of the frequency. Most of the important practices, reduction of the broken rail, non-destructive inspection, and it includes the several technology methods that there are in heavy haul industry today with the objective of obtaining the full length life of the potential rail section. The technologies methods are more capable of performing accurate, reliable, effective testing in an ever-changing environment while acceptable speed will not interfere with the service functionality of the railroad. Detection methods. Current detection method was to perform any using the various types of test equipment process with the sum of the human involvement with the interpretation of the testing data listed below. For these processes, portable testing process. The portable testing process consists of an operator pushing a test device over a rail with a walking piece, visually interpreting the test data on the flaw detector. When a suspected defect is identified, the operator will stop, manually verify the defective the location of the defective that is logged and reported to the railroad with remedial action. Present no permanent record of tests stored in the future analysis. Start and stop test process. Start and stop process is a vehicle based on low speeds, usually not excess of 30 to 40 kilometers an hour. The vertical travels, all gathering the data presented by the operator in real-time interpretation. Once the suspect equipment, the response identified by the test operator, the vehicle is stopped, proceeds back to the suspected location. Location is verified. The operator determined the defective, classified, reported the immediate remedial action. This process procedure, permanent record of the test of the future analysis. The chase car test process. The chase car process is a variation of start and stop processes. The process consists of the lead test vehicle performing the flaw detection performance advance of the chase car. Once the lead test vehicle encounters the equipment in response to the represented with the suspected defective condition, a copy of the test data electronically transmitted back to the chase car. Verification location verified by the chase car operator, allowing the lead detector of the car to continue with the test for the purpose of the prospect. This is increasing protection while maintaining the ability to report the defective condition with remedial action into the railway or permanent railroad. The test is produced with the defector and the chase car with a future analysis. And fourth, continuous test process. The continuous process continues operating high-speed vehicle based on the time testing system nonstop along with a designated route, sometimes covering over an excess of 100 and 300 kilometers per shift. The test data is analyzed according to defined standards centralized. Once the analysis reports are sent out, the verification staff at the Viva the Internet verifies the suspect to conform the defects using the portable test unit and the portable handheld flaw detector. Verification reports transmitted back to the railroad over the Internet record. It's proper the remedial action. The process proceeds with the permanent record of the test of the future analysis. Current technologies. Current technology. The primary technology using non-destructive testing of the heavy haul lines of the ultrasonic and the induction testing process. The ultrasonic technology is mostly frequently used in induction, currently used in the complementary system of the ultrasound only. Described as follows. Induction. The base induction testing required for the introduction of the high-level directed correction current in the rail, establishing a magnetic field around the railhead. Induction test process. The magnetic field, the consideration reason consisting of concentric lines of the force perpendicular with the railhead on the magnetic field is established with the remaining consistent with the strength and the shapes of the longest rail weight and the railhead contour. Current flow of the remaining constant. The current field is generally around 1200 A to 3600 A. However, it can vary for the railway length and test speed. The introduction of the current is applied with the using of the two set of electrodes that are placed on the railhead, and the spacing between the electrode is set approximately 170 centimeters. Current flows into the railhead of the flow forward electrode set through the trailing electrode set. During this process, the railroad head becomes an electric circuit which flows longitudinally through the railroad head. In the induction sensor, this pass through magnetic field. The unit contained the induction sensor is located in the two sets of brush and preset distances above the surface of the railhead. The clearance must be maintained throughout the continuing of the testing of the ensure the testing integrity. When the motion is introduced, the sensor on unit moves and the magnetic field detects the distortion concentric lines of the force established magnetic with the electromotive force is induced. The electromotive force is measurable. The voltage and sensor of the unit pass through the magnetic field. There's no distortion. No electromotive force is measured. In modern railway weights only head in the top of the part of the web saturated with the current as current with the flows of the rail. Any condition such as defect will distort the current path. The distortion of the current flow will also lead to distortion of the associated magnetic field. As the distortion of the magnetic field is detected by a search unit. The search unit houses multiple sensors aligned with the various planes of the relation with the railhead. Multiple sensors are arranged with the various planes and relation with the railhead and are used to allow the detection of all components of the magnetic field disturbance. The signal received by the sensors are sent to the test system and evaluated to determine if they have met or exceed the set of thresholds. If the signal is exceeded predominantly predetermined threshold level, the data is presented with the operator interpretation of potential defect. The proposed data is then kept in the permanent record of the test, and very important the system is allowable to saturate the railhead electrical current, and the quality of the test can be jeopardized. The ultrasonics are briefly described as sound waves, vibrations, and propagation of the frequency that is above the range of the human hearing, normally above the range of 220,000 hertz or cycle per second. The range normally used during the current flawed detection operations 2.2 million megahertz cycle per second, or 5 megahertz. The ultrasonic test method for the railway testing is described briefly as follows: 1. Ultrasonics generated onto the rail for the various angles piezoelectric transducers that are manufactured with the ceramic materials. The transducers are conducted with the wheel assembly and sled device which rides on the top of the rail. The ultrasonic produces applying with the voltage of the transducer itself. 2. The wheel sled and contained with the transducer is commonly referred to as the search unit. The transducer is positioned with several different angles of the ultrasound produced. So the transducer normally covers the rail at the top of the railhead through the web to the bottom of the rail, entire with the width of the railhead and with the use of the portion in the center of the rail, and currently not covered with the current testing system. Ultrasound is generated with the rail of all angles associated with the system, and the test speeds up to 100 kilometers an hour. In conditions with encountered insufficient size and orientation would the reflector of the ultrasound transferred with the ultrasound reflected back in the respective transducer. The conditions will include the railhead surface conditions, internal visible rail flaws, and well upset finishes, but known as reflectors in rail geometry, such as drilling and rail ends. The information is reflected back to the transducer and processed in the test system, recorded with the permanent test data on consolidating displays of an ultrasonic channel. And the effect of an ultrasound produced with the transducer travels through the rail specimen with the top of the railhead. If the sound is uninterpreted, no reflected sound signal is returned to the transducer. If the conditions such as railhead surface irregularity, rail geometry, reflector, bolt hole, drilling, welding, upset finish, or rail end, the internal rail fall ultrasound produced with the rail back of the transducer and equipment responsible presented with the operator interpretation. The information processed with the test system maintained with the permanent record of the test system that are used with the haul lines, normally with a minimum of 24 hours. The test channel 12 on each rail, and however the recently system of the accommodated with the 24 hours 24 channels and additional wheel sled angle test probes that have been developed. Flaw detection limitations. Ultrasound has been primarily non-destructive method of the internal rail flaw inspection, as within the non-destructive testing method. Ultrasonic technology contains the physical limitations that allows certain types of railheads conditioned to stringently in all influencing detection and rail flaws. The predominant types of the mechanical form conditions are referred to as shell or shells, engine dry burn, spalling, flaking, corrugation, head checking, or other conditions that are encountered in heavy lubrication and debris and railhead. Chapter 8: Rolling Contact Fatigue.